foremost, we're going to find a domain. It should be number 1, but it's not. You can't find your range yet, but you can find your domain. Your y-intercept, you know how to do your y-intercept. You plug in an x for 0, you solve for y. It's not a bad thing to do when it's irrational. It kind of works itself out when you notice when you plug in your x for 0. Your x-intercept is a little bit different. Your x-intercept is going to be your zeros of your numerator. And this is going to be after we factor. So the first thing we're going to have to do, and... Okay. All right?
Yes.
Went down the wrong pipe. We're going to set your numerator to 0, and we're going to look for your x values. That's a little different than we've been doing. You have 2 sets of asymptotes. Actually, you can possibly have 3. We have a vertical. This is from your denominator. These are things, x values that you cannot use. We're going to find this after we factor and reduce. Put a little star next to this. You can have 1 vertical, no verticals, several verticals. Your function can never, never, never cross a vertical asymptote. Never cross it. Your horizontal asymptote determines your end behavior. You know, sometimes you have an asymptote here and you came along like this, and then it has to come back like this and go up here somewhere. Well, somewhere in here, there's a horizontal asymptote that also guides these end behaviors. And we very, very lightly talked about this when you did that chart that you were doing with the asymptotes. Sometimes we can spot it, sometimes we just follow the rules and you'll see it. So there's 3 basic rules, and we'll go through these rules. It goes by the highest degree of your rational function, and we'll talk about this when we get there, because it won't make any sense to talk about it now. The third possible asymptote you might have is a slant asymptote, this guy down here. This has a special case. If the degree in the numerator, say it's x to the 4th, and the degree in the denominator is 1 less, you have a slant asymptote, which causes your graph to go like this. We've seen this happen, and there's a slant asymptote that goes in here. And a slant asymptote is nice also. You can put it in your y1 to y2, and you can see if your graph hits it. We still do concavity. We still do max and mins. We still do increasing, decreasing. Increasing, decreasing are going to be a little bit different because sometimes you're not going to have that max and min. This obviously is clearly max and min, but when you do these guys and they come across like this, this has no max or min here. I'm not just doing this, but it has no max or min there. So we're going to look at some of those things. We always sketch, we talk about concavity, and lastly is a point of discontinuity. A point of discontinuity we'll look at probably in another day or 2, because that we look at by itself. That's a whole different animal. It's something that we factored out of your function, but we can't factor out something and just make it disappear. And it's usually one of these little points that you see when you do this. Just to give you a hint, it goes like this. And you can see it on your graph that it goes like this, but there's one little value in here that you can't use because it was stuck in your denominator before we factored it out. So there's a little point that we can't use, and that's called the point of discontinuity. When we did your difference quotient, remember the h? We had to eliminate the h in the denominator because we said as h approaches 0, we can't use a 0 in that denominator, but we could fill it in if we could eliminate it. This is kind of like your point of discontinuity. Next year, if you take calculus, you'll do limits with this. It'll reach a limit, and we'll do limits at the end of this course as well. We'll get you started into the calc part. But it reaches like a little limit here. I could fill this in. Some are removable, some are not removable. They jump. So as we go through those, we'll talk about those. So we're going to start very, very basic and do the first rational function. So put this in your y equals Don't sketch it yet. Just put it in there first. Just first put it in there and see what it looks like. I like to sketch your asymptotes first before we actually do the sketch. It makes it easier for you to do the sketch. So you see something, ignore this thing here. My eraser. Okay. All right, so you see something that looks like this so far. Something that looks like that. Something caused that break. What caused that break in that graph? The asymptote. Where did that asymptote come from? The x squared in the denominator. So let's start with your domain restrictions. Always do this first. Domain restriction. I can't have a 0 in my denominator. So therefore, I have to remove this 0 from my domain. So my domain says I can use anything but the 0. That's why there's that break there. There's a break in that because I'm not allowed to use a 0. Okay. The range we're going to hold off on because we don't know where that little break is horizontally, so we don't know what y values we can't use yet. Okay, so follow your sheet that we just had. Your y-intercept, easy guy. X is equal to 0. So if we put a 0 in for x, can we do this? Can we divide by 0? So do we have a y-intercept? And did you see your graph touch your y-intercept? Nope, that's where your asymptote was. No y-intercept. Okay. X-intercept, we're going to hold off for a second. Can we factor this? Reduce this at all? Can we cancel out an x? Please tell me no.
No.
Good, very good. Can't cancel out any terms. So there's nothing to factor. So now, my x-intercept, make sure you're writing this down. Zeros of the numerator. God bless you. If you don't write this down and you go to do this for homework, you're going to miss half of the stuff. So after we've factored and reduced, which we can't, we take your numerator. We set it equal to 0. We subtract 1, divide by 4. So here's my x-intercept. Is that reasonable? Does it look like it crosses over there at the negative 1/4, 0? It's in the negative area. It's real close to the 0. Close enough. Your calculator probably kind of like stops over that axis a little bit. All right. So the next thing we're going to look at is your vertical asymptotes. A vertical asymptote says anything left in the denominator. After factoring and reducing, look at this chart. After factoring and reducing, go to your denominator. Whatever factors are in the denominator, set them equal to 0. And we knew this. We knew that we couldn't use a 0. So this is my vertical asymptote. Let's see if I can color it. So my vertical asymptote, yes. Yep. Zeros are the numerator. So this is x equals 0. It happens to be my y-axis. There's my vertical asymptote. My horizontal asymptote. I got something that's affecting this, don't I? Something that's making these ends behave the way they do. This one's going out like this side's going out like that. Something is forcing that to go that way. That's my horizontal asymptote. Now, kindly read the sheet with me. If the degree in the numerator is less than the degree in the denominator. So let me check. My degree in my numerator, the highest degree is 1. The highest degree is the highest degree. The highest degree in my denominator is 1. So is the degree in the numerator less than the degree in the denominator? No. Is the degree in the numerator equal to the degree in the denominator? Yes. Then I take these coefficients out. I make A over B, it's called. This is my coefficient of my top over the coefficient of the bottom. So y is equal to 4. When the degrees are the same, you just take the leading coefficients from top to bottom. Be careful, sometimes the highest values are not always front, and sometimes they have to be multiplied out. So I take this, and here's my asymptote right here. Y is equal to 4. This is causing my end behaviors to behave like that. Now, sometimes a graph of a rational can jump a horizontal. What happens when it jumps a horizontal? Look up here one moment, please. So say this is my horizontal. Here comes my graph. It's coming down. It jumps over this, but then it still has to behave with this guy. It says, this is your horizontal asymptote. I'm going to tell you where your ends go. It has to follow along this asymptote. If it jumps it, it's got to come back and follow it. So it's still guiding the end behavior for this function. Okay, so now we have our asymptotes. Now this makes it easier for you to graph. So when you graph this, start like this. Here's your graph. Put your asymptotes in. And now it's much, much easier for you to get this. See it? And this guy goes like this. See your graph? Once you do the intercepts, once you do the asymptotes, your graph falls right into place. Okay? Now you did your intercepts, you did all of this. What else do we have left to do? We can do our range now. Now we can do our range. So what is my range? What is the one y value that we took out of this? 4. Why did we take that out? It's a horizontal asymptote. Good, Therese, good. It's a horizontal asymptote. God bless you. I'm not touching that. I'm guiding alongside of it, but I'm not touching it. So my range now says you can use anything except the 4. Kind of like this with the 0. Just jump over it. Generally, if you're looking for a max or a min, or you're looking for an asymptote, you have to wait to the end. The reason we can do this now is because we don't have a max or a min. These guys are no maxes or no mins, because if it was a max, this guy's higher. If this was a min, this guy's lower. So these little curves don't have a max and a min to them. So we say no max, no min. Good? Okay. And now all we have left to do is increasing and concavity. So the increasing, decreasing part says, follow from the left to the right. What is this function doing right here? What's my y value doing? From here to here. It's decreasing. So my decreasing part says what? Negative infinity to what x value? 0. I'm decreasing. Then, what's it doing from here? From the top down, I jump over here, left to right. What's it doing now? Still decreasing. From where? 0 to infinity. I have no increasing. Just follow from left to right. Read your x's from left to right. Where are your y's going? And the last thing I have is concavity. Now, concavities usually are a little easier in this. This guy from the left to the right, is this technically, am I making a cave up or a cave down? Good. So from negative infinity to 0, I'm caving down. This guy, if I start up here again, from left to right, I'm kind of making a cave up. Even though I don't come back up with it, it still has the upward motion of this. If I enclosed it, I could still see my cave up. From 0 to infinity. It's a hard one to see, but that's still a cave up. Yes. Yes. Yeah, there's no pass, just go ahead. Are we okay with this? Question. Okay, you're reading your x's from left to right, but you're looking for your value of y. So if I'm starting here at these x's, what is my y value doing as I move my hand? Decreasing. If I come here, because I have to jump over this asymptote, what is my y value doing from here to here? Decreasing.
So for these ones, it's for the y values and not the x.
Always, we give the x value intervals, but we're always looking at the y value. When you did this, these guys, from left to right, as my x went up, increased, my x was moving left to right, my y was increasing. Then what happened from this x to this x? My y decreased, not my x. My x is still moving to the right. Then from here to here, my y increased. I'm always looking at the value of my function, which is my y, but I have to give it to you over the x interval. Because how am I going to tell you this y goes from 0 to 2? Where? Where does it go from 0 to 2? This y goes from 2 to infinity. Where? Where do I go from 2 to infinity? Negative 2 to infinity. Where do you want me to do that? Just make a graph and say negative 2 to infinity. 2 to infinity. Where do I go? I have to give it to you over an x interval. That part doesn't change. Are we good with this? This is a little different. This is not a continuous function, and you need to have this sheet. Good? Yeah.
So, in the first sketch, you didn't draw arrows, and that's because it wasn't like as clear a graph yet, right?
There always should be arrows there. I just probably just wing a graph up there. I just sketched my graph up there. Yeah, I wanted you to first get like the kind of the concept of it, but once you draw your asymptotes, isn't it easier to draw? Once you get your intercepts and your asymptotes, your graph will slide down. Sometimes your calculator doesn't do a great job with this. So sometimes your calculator will look like this, and it will just stop right there. Like, what is my graph doing? Did it actually go below it and come back up? Did it stay like this? I don't know where it went. So once I do my asymptotes and then I look at my table, I can see where it goes. If it does dip below, and we won't do one just yet, then we have a minimum. But right now, we have a smooth little curve. We're just keeping it simple right now. Okay, let's try another one. Take the next graph and put that in your calc, please. Okay, so you should have something that, oops, nope, no, sorry, I got the wrong graph. I wrote the wrong one down. Okay, so you should have something that looks like this. Agreed? So just by looking at this graph, Can you give me one asymptote? Any asymptote. Look carefully. Watch the ends of your graph. Why is my graph going like this? Why is it going along here and why is it going along here? There's a horizontal asymptote. What would you guess it to be? Y equals 0. So we're guessing this to be y equals 0. There's something else that's causing these guys to go up. 1, -1, could be, right? I could kind of see like a -1. I could kind of see a 1 in here. I see something happening to the ends, right? They're not behaving nicely. They're not a normal curve that I could follow with my finger and trace up and down and never have to take my finger off, right? I have to pick up my finger. If I'm coming from left to right, I got to stop here. Whoops, I got to jump back up here. Whoops, I got to jump back over here. I got to do a number of things. So something is not behaving nicely. So the first thing we're going to look at is your domain. When you take this guy, set it equal to 0, what can you not use? Plus or minus 1. So your domain says -infinity to -1, jump over it, -1 to 1, jump over it, and 1 to infinity. Can you see now where those asymptotes just came from? Does it verify that we can't use a -1 and a +1? This is what's causing this. So now, hang on to your range for a little bit. Let's do your x-intercept. Let's do your y-intercept first. That's always the easier. So we're going to plug this in. 3 times 0, 0 squared minus 1, so we get 0 over -1. So your y-intercept says 0. Do I spot a 0, 0 there as my y-intercept? That looks good to me. Okay. My x-intercept. Can I factor this guy at all? Not factorable, right? So my x-intercept says zeros of the numerator. This is so important because this is different than what we do. I take 3x and I set it equal to 0. Does that confirm my 0, 0 also? Okay. Let's go to our asymptotes. Let's hit a vertical asymptote. I'm going to start graphing as we do our asymptotes. Vertical asymptote. What does vertical asymptote say? Where should I look? What does your sheet say? The zero's where? In the denominator. After we've factored it. Did we agree we can't factor? So therefore, when I set this equal to 0, x is equal to 1, x is equal to -1. Same as my domain right now because I couldn't factor anything out. So I'm going to build my asymptotes right here. X is -1, x is 1. Didn't we notice that's where our graph was behaving differently? Those ends were following something, right? They were kind of broken. They didn't continue through. Okay, let's do a horizontal asymptote. Look at your horizontal asymptote says. The degree in the numerator. What's the highest degree in the numerator? 1. What's the highest degree in the denominator? 2. So follow your sheet. When the degree in the numerator is less than the degree in the denominator, what's my asymptote? You got to read your chart. Y equals 0. I'm right here on your paper. Horizontal asymptote. If the degree in the numerator is less than the degree in the denominator, which is 1, is less than the degree in the denominator, which is 2, then y equals 0 is my asymptote. So here's my asymptote. Weren't we seeing that behaving my ends a little differently? So now, we know it's crossing through the 0, 0. Let's push this through. I can come through like this. Watch. Here's my graph. Notice it jumped over. It went right through a horizontal asymptote. You're allowed to go through a horizontal asymptote. A vertical asymptote, never, because that's a domain restriction. This part went like this. Use this asymptote, and guided it. See it? It used this asymptote and this asymptote and guided the end behaviors. Make sense? We use our asymptotes to guide your function because it is not continuous. It's a little different. Can we do the range now? I'm going to squeeze the range in over here. Were there any values that we couldn't use of y's? But what happened? We ended up with an intercept of 0, right? You would have thought it was 0 because y equals 0 was an asymptote. But what happened to your graph? It used an intercept of 0. So it jumped through that horizontal asymptote, which it can, because that horizontal asymptote is there to guide the ends, the end behaviors. Because if I didn't have this, where would this piece go? I wouldn't know where this piece went. I would keep on going up. But that's there to guide my end behaviors. A horizontal asymptote, your function can jump over it, and tomorrow we'll probably see one, or maybe the next day. Like if this was my horizontal asymptote, this can sometimes jump over it, but then I still need to use it as an end behavior. This guy didn't. It came completely through it. It used the vertical. It can never jump a vertical because that's your denominator restriction. You can never use those numbers. But it can cross over horizontal. It's there to guide end behaviors mostly. This one is an exception. So now, let's look at, what do we have left? Let's look at mins and maxes. Do we have any max and mins here? Any relative max and mins here? Nope. Why isn't this a min right here? Or a max right there, rather? Why isn't that not a max? It doesn't come back down. Very good. It doesn't come back down. It keeps on going this way. So this is getting higher over here, lower over here. These guys are neither maxes nor mins. So we have none. And that's okay. Let's do increasing, decreasing. Okay. We're following your x's from the left to the right. First x I hit is this one. This x, I'm watching my y values. What are my y values doing in this section right here? Decreasing. Aren't my y values getting real close to that axis over there, but then eventually getting lower and lower and lower? This is my decreasing part. Negative infinity to where? Where's my asymptote? -1. Then I jump up here. What is my y values doing here? Decreasing. So from -1 to where? 1. Then I jump again. I'm back up here. What are my y values doing here? Decreasing. I have no increasing intervals here.
What does that be, 1 and not -1?
That would be 1. Yes, thank you. I have no increasing intervals here. Yes. Yeah, sorry, the range was all real numbers. Sorry, I didn't write it in. We had no exceptions in this because one would have thought the 0 was there, like we said, but it crossed over the 0. It had an intercept. So there were no eliminations. We had all real numbers. And this little middle part kind of showed us all real numbers. If you have one graph that goes through everything, there's your real numbers. Let's do concavity. I have a concave up. I have a concave down. Now, let's just do the outside ones first. What is this piece doing? Concave which way? Down. So let's start with this one. Negative infinity to -1. He's concaving down. Okay, what about this part? Let's go to this one. What's he doing? He's concaving up. And how do I write that? 1 to infinity. Now, watch my pen a minute. I'm coming in this section right here. I'm going down like this. And I kind of switched directions and went like this. Technically, I was trying to make a concave up, but I changed my mind. What's that point called when I change my mind? Inflection point. Good. So where's my inflection point in this? 0, 0. So then I decided instead to concave down, even though I'm missing the other part. This one's a little tricky to see. So this part here, I kind of had a concave up. So this concave up says from -1 to 0. And then at this point, from 0 to 1, I changed my mind and I concaved down with a little inflection point at the 0, 0. A little tougher to see. Okay. So are we kind of getting a better feel for this? A little different. You actually, please sit with this sheet in front of you with the definitions and follow the ones we did as examples step by step. If when you do your homework you forget what we did, pull up the video. If you can't access Edmodo, use my YouTube. It's my first name and my last name. That's an R. Use my video. Walk through it step by step with one of your homework problems. This one's very, very different. Very different than what we've been doing. You kind of have to get the hang of what are my horizontal asymptotes, where are my vertical asymptotes. Once you get the hang of that, it makes life a lot simpler. It makes you understand why this isn't continuous. Why this isn't so easy as the other ones. Yes, you can go. Oh wait, I didn't hint at the homework. Okay, so the homework is this. I'll give you guys I won't be today. I'm leaving Saturday today. Because we had to eliminate these. Because they were in the denominator, we had to jump over them. Oh, no. Yeah, I'm sorry. You had good participation, guys. Ask good questions. This is difficult. This is a difficult section. And if you despise fractions, it's always a little tougher.